Alright, so let's start with the lipids here. Alright, so it's a biomolecule, which we know that. Alright, they don't have a particular functional group. Okay, they're not like amines, they're not like alcohols, so lipids are classified, but there isn't a specific functional group that you're looking for it to be a lipid. So therefore, our lipids could have multiple different types of structures. So for instance, a steroid versus a triacylglyceride and so on. All right. Soluble in organic solvents but not water, our lipids are nonpolar. Okay, they contain nonpolar carbon to carbon and carbon to hydrogen bonds, and they have very few polar bonds, which again makes them insoluble in water. So the carbon to carbon, carbon to hydrogen bonds, so we're looking at a lot of London forces between them. Nonpolar bonds. So three things that lipids are for. They store energy, our fat cells. Chemical messengers, okay, they're found in our nerve fibers and hormones. And they're parts of the membrane. So limiting your amounts of fats is okay, but completely cutting out fats is not okay, for the fact that we need some fats in our diet in order to make the membrane and to store some energy and things like that. Okay. So as it is to be unhealthy to be overweight and have too much fat cells, it's also unhealthy to be underweight and not have enough fat storage and not taking in enough. We could break our lipids down even further. Okay. You got your simple lipids, which are your fats, oils, and waxes. We got our complex lipids, okay, our phospholipids. We got steroids, cholesterol, and our steroid hormones. And eicosanoids, all right, are our last. So we'll talk about all four. We'll talk about the different areas, the different things, the storage, the cell signaling, all of that. Okay. All right. So how do we start to categorize our lipids? Well, we could start, can they be hydrolyzed? Okay, by water. Can water break them down? So some of our lipids can be converted into smaller molecules. All right. We could turn our lipids into waxes, we could turn them into triglycerides, or we could turn them into phospholipids via doing a hydrolyzing reaction. So they're not going to be soluble in water, but reacting them with water could result in these compounds forming. We also have the ones that can't be hydrolyzed. Okay. We do aqueous hydrolysis and nothing happens. Those are steroids, our fat-soluble vitamins, all right, and our eicosanoids. The majority of the ones that could be hydrolyzed have some sort of ester linkage. Okay, the ones that can be broken down into smaller parts via water, okay, have some sort of ester linkage. Now, to review, we talked about esters and why they have to stay dry is because if there's water present when we create an ester, it'll turn back into the alcohol and the carboxylic acid that made it. Okay, so this was actually this reaction going this way, right to left, was actually the reaction that I had you draw on the exam. All right, when I asked how would you make this, whatever it was, I think it was like number 5 or number 6, how would you make this? All right, ester. All right. So let's start with fatty acids. Fatty acids is a carboxylic acid. We talked about that when we talked about carboxylic acids, but again, reviewing here. Our fatty acids are a long chain of carboxylic acid. If it was a shorter chain, the shorter chain would be soluble in water because this end again is polar. Okay. As I add more and more carbons, this whole end is nonpolar. Okay. The more carbons I add, the more nonpolar. There's like a cutoff there. You know, same with alcohols. Right around 7, 8, something like that, we become more and more insoluble. So we're looking at typically for our fatty acids anywhere between 12 to 18, they say 20 carbons here. Our fatty acids have an even number of carbons. We could have odd numbers, but we like to stay even. And the reason we like to stay even, and I'm not going to get into it too much, is that when we break down our fatty acids, we break them up into, and you'll get this in biochem, those of you who have to take it. We break it into 2 carbon chains. So when we metabolize, whoops, that's over too far. When we metabolize our fatty acids, we metabolize them in a 2-step or a 2-carbon chain essentially. So 1, 2, then 1, 2, then 1, 2, then 1, 2, and so on. So we keep cutting here, 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 essentially, and so on. So that's why the fatty acids that we normally have in our body are even numbers, because of the beta oxidation that it undergoes. Now that doesn't mean we can't break down odd numbers. We can. There's a method, there's a process, but it's not as easy because it's odd numbers. We would break it into 3 at the end, and there's a whole thing to do there. Okay, and they are insoluble in water because we are going to store these as our long-term energy source. We're going to store them as our long-term energy source. There is a specific way to name them biochemically. I'm not going to hold you responsible because this isn't a biochem class. We don't use IUPAC in biochem. So this would be palmitic acid, which is a 16-carbon chain, all single bonded. If it's all single bonded carbons, we say it's saturated. So saturated fatty acid chains are all single carbon to carbon bonds. I know there's a double bond oxygen over here, but again, we're looking at the carbon to carbon single bonds. Okay. The term hydrophilic and hydrophobic again, liking water, the polar end likes water, the hydrophobic end is the nonpolar chain. Here's stearic acid. Stearic acid is 18 carbons long. Okay, and with stearic acid, this is the one you usually see used for soaps. Sodium stearate is usually the way it goes for soaps. We already talked about soaps in a previous chapter, but this is usually the breakdown or the compound that's utilized. Okay. Saturated fatty acids are the ones that are solid at room temperature. They're packed closely together because of the single bonds. They're allowed to pack closely together. Therefore, they have maximum London forces, maximum interactions between the carbons of each one of these fatty acid chains. There's no steric hindrance. There's no double bonds changing the shape. There's no nothing getting in the way to allow for maximum London forces. Therefore, maximum London forces takes higher temperatures to melt it, therefore solid at room temperature. We're talking about our butter and things like that. Okay. So saturated fatty acids, all single bonded, maximum London forces, solids at room temperature. Unsaturated fatty acids. Oleic acid is a good example. Okay. Oleic acid, as you could see it right there. And we are usually in the cis form. To be an unsaturated, I just need to have one double bond, but I could have more than one double bond. Okay, it is possible. So oleic acid is what you get in sunflower oil or olive oil. It's found in avocados. Okay, some nuts, some cheese. All right, all has this, but this is the acid. Excuse me. The good, if you want to say, fatty acid that you find in olive oil. Okay. The liquids they're liquids at room temperature, and the reason being is they can't closely pack together, because even if I have some saturated mixed with that unsaturated, that cis double bond right here is going to not allow them to pack as closely together. Therefore, our London forces are going to go down. Therefore, it doesn't take a higher temperature to make it a liquid, and that's why our oils are liquid at room temperature. Okay. So the good news is our body is capable of synthesizing most fatty acids from carbohydrates or other fatty acids. So here's the deal. You limit your fats. You're not eating fatty foods. You're not doing anything like that. But you're eating a lot of carbs. You're eating a lot of pasta. You're eating a lot of breads and things like that. But you cut down on your fats. You're not eating, French fries and things. And then you go and you get your blood work done. All right. Or, those of you who want to go into the medical field or PA school or whatever. And, you see this person. They insist they've cut down on their fats. Carbohydrates can turn into fatty acids, so when you test for your triglycerides in your blood, your triglycerides could still be high if you're loaded up on carbohydrates. Because your body is capable of turning those carbs, those leftover carbs, into fats and storing them for later use. So your quick energy, if you're not using all of your quick energy up, all right, remember your carbs break down to give you your instant energy via glycolysis. Okay, and we kind of mentioned that early in another chapter when we were just randomly, I was going off on one of my tangents in lecture and we were just talking about it. But any leftover that we're not using for that quick energy can end up being turned into fatty acids. The issue is we don't make enough fatty acids that have more than one double bond. Okay, which we need. Okay, fatty acids that contain more than one double bond are called essential fatty acids, and we need to provide them in our diet. Now, we could get those directly from eating animals. Okay, we can eat animals, and we'll break down their fatty acids, or in source use their fatty acids to do this. That's why if you want to cut meat out of your diet and things like that, you have to make sure that you're supplementing some sort of, non-meat substitute. And I don't mean something to substitute meat like to, make a meatloaf or a hamburger. All right, but you'd have to substitute something that would get you these essential fatty acids, or something that would allow it. All right, linoleic acid is a type of essential fatty acid. So where can we get it from if we don't want to eat meat? Nuts, avocados, olives. All right. Yes, they have oleic acid, but they are rich in essential fatty acids too. So it is possible, okay, to eliminate meat and still get all the essentials that you need, as long as you understand that you need to replace those essentials. So that's why I always say, it's fine. You want to be a vegetarian, or you want to be a vegan, or you want to be whatever. Just make sure you just don't just one day decide it. Make sure you do your research, or you talk to a nutritionist, or you talk to somebody that can help you, for the essential fatty acids that you'd be missing with your meat. What can I substitute? Okay. So omega N acids, okay? The N stands for where is the first double bond? All right, so linoleic acid is an omega-6 acid. So when you look on the back of a package, now you should understand what those mean, okay? Omega-6 fatty acids tells you where the first double bond is. All right, and linoleic acid, again, left to right. It's on the 6 carbon left to right. I know what you're going to tell me, but shouldn't we start the count from over here? Shouldn't we start where the functional group is? And this is 1, 2, 3, 4, 5, 6, 7, 8. Shouldn't this be a 9? Again, we're not using IUPAC. Biochemistry-wise, you go left to right. You don't look for a functional group. You go left to right and you count. 1, 2, 3, 4, 5, 6. We're there. Okay. Omega-3. So that's why you could buy your fish oil supplement. It says omega-3s or contains omega-369s or things like that. So, again, here's our omega-6. Again, left to right. All right. Here we have a omega-3. Still the same length, linoleic acid, but now it's an omega-3 because we added another carbon chain. Or sorry, another double bond to the carbon chain is what I meant to say there. All right, and the source of omega-3s, fish, but you don't want to eat fish, okay? Brussels sprouts, sunflower seeds, different types of seeds, walnuts, eggs. You want to go strictly vegan, no eggs, no fish, okay? You got your walnuts still, you got sunflower seeds, you got, those are the pills themselves, Brussels sprouts. So there's places to get these in your diet that we're needing. Okay. So any questions on essential fatty acids or difference between saturated and unsaturated? Okay, so then let's talk about waxes. Waxes are esters. Straightforward, they're esters. It's an alcohol bonded to a fatty acid. But the key is, in order to be a wax, I need 2 factors. Okay, and the 2 factors are right there in the definition. It has to be a saturated fatty acid chain, which means all single bonds. Number 1, it can't have a double bond in it. Number 2, the alcohol chain has to be long. I'm not using ethanol, methanol, propanol here. I'm using octanol, decanol. I'm using long alcohol chains. But all they are esters. Right there, that's an ester linkage. But the key is this has to be saturated. And this chain right here has to be long. All right. Okay. So spermaceti wax is the wax that covers the head of sperm whales. All right. Protect their bodies essentially from losing water, their heads losing water and things like that. But it's a reaction of palmitic acid. And look at the alcohol chain. The alcohol chain is a 16 carbon alcohol chain. So you're talking here, palmitic acid, which is a saturated, all right, has 16 carbons, and we're reacting with a 16 carbon alcohol. So in theory, you're getting 16 carbons on the right and 16 carbons on the left of the ester bonded. That is a lot of carbon-to-carbon nonpolar interaction to make waxes very, very nonpolar. Here's beeswax. Look at the alcohol chain that was used. A 30 carbon alcohol chain. Okay, in order to make beeswax. Very hydrophobic stuff. All right, what's the purpose? Again, they provide a protective coating. Ducks have it. All right. Waterproofing on skin and fur. We have a protective coating too, so that we don't dry out essentially. All right. Don't dry out, and we have a protective coating on our skin so that if we're in water, all right, we're not gonna have that water essentially coming directly in contact. But plants are, prevent water loss. We do it to our cars, right? We use car wax on our cars. The water beads up. It's a protective layer. We're doing the same thing here. We're not plants, so we don't have to worry about drying out per se, but they are protective coatings. So we can use it on our floor. Jojoba, used in candles, lipsticks. Lanolin from wool can be used in lotions. All right, so stuff you come across every day that you might not think about as being waxes per se. I mean, we think of car wax as waxes, and we think of waxing a floor and putting a protective coating on it as waxes. But candles, do you really think about them as being a wax? Crayons, lipstick. Do you think about lotions being a wax, a form of wax, a form of, hydrophobic kind of things? Okay. Waxes, like other esters, can be hydrolyzed. But they could be hydrolyzed. Well, you just said they bead water and they protect us from water. Why wouldn't they get hydrolyzed right away? Well, in order to hydrolyze a wax, you need a couple things. Number one, you need water, of course. Number two, you need an acid. And number three, you need heat. Okay, so to break your wax down into the fatty acid that made it plus the alcohol, you need 3 factors. So it's not an easy process. Just add water and boom, I'm back to my ester and my alcohol. My carboxylic acid and my alcohol. Okay. How about triacylglycerides, or triglycerides as they're known in everyday life or common name? All right, their fats and oils are stored in the body. They're an ester of the alcohol glycerol. And they're produced via Fischer esterification, which we talked about. These are our vegetable oils. Okay. So, here is glycerol. All right, let me again, let's do this color. So here's glycerol. Glycerol, all right, is a 3-carbon trialcohol, trihydroxy alcohol. So if we were naming this, it would be 1, 2, 3, right? 1, 2, 3. Propanol, right? Or prop and 1, 2, 3 all, however you want to name it. Okay, it's a triol. This is glycerol. My fatty acid chains come in. Okay, my fatty acid chains come in and they link to the glycerol, just like we would in Fischer esterification. The difference is, instead of reacting a fatty acid or a carboxylic acid with one alcohol and making our ester linkage, our alcohol has 3 alcohol groups, 3 OHs that are available to make that ester linkage. Hydroxide, hydroxide, hydroxide. What are we going to do? We're going to drive water off. We're going to drive water off. Okay, we're going to drive water off, and we're going to create an ester linkage. All right. Now we'll do that 3 times and we'll create 3 water molecules. And this is how they're stored in the body. But it's all organic chemistry that's allowing it to store. We're doing just like you would in lab. Just like you did when we made banana oil. An alcohol plus a carboxylic acid yields, our ester. We're doing the same thing, just on a bigger scale with longer carbon chains. Now the thing is, we'll store these, and when we need the energy, we'll take them and break them apart. We'll reestablish, we'll hydrolyze them. We'll reestablish the glycerol that could then store more fatty acids. There's the term simple triglycerides versus mixed triglycerides. Simple, they have the same identical fatty acid chain bonded to them. Mixed, they could have different fatty acids. Okay. And usually with mixed, there's at least one unsaturated. With the identical and the simple, they're all saturated. Okay. But you may see an unsaturated. You may see 2 unsaturated. You may see 3 different saturated ones. The thing is, okay, we need to have a mix here. All 3 of these could be unsaturated. In our case here, like I said, they're showing that all of these are the same saturated, these are the same saturated, but this is a different unsaturated. So there's no, hey, okay, I'm going to be mixed. I need at least one unsaturated. Not necessarily. I'm going to be mixed as long as the three side chains do not match. Okay. And we can break it down even further. Saturated triacylglycerides contain only saturated fatty acids. Monounsaturated means I have one carbon-to-carbon double bond. Polyunsaturated means I have multiple carbon-to-carbon double bonded chains in there. The more double bonds in the fatty acid chain, the lower the melting point of the triacylglyceride. Very important right here. Star it, ostracize it, whatever you need to do. The more double bonds, the more unsaturated I am, the lower the melting point. And the reason being, the more unsaturation, the less London forces, therefore the less energy needed. So let's think about that. What do they tell you to eat? All right. What fats do they tell you to eat? Unsaturated fats or saturated fats? Okay, they tell you to eat unsaturated fats. Why? Well, saturated fats, all right, are going to cause an increase of cholesterol. Saturated fats are not going to be, they're going to be more solid than liquid. They're going to start clogging things. Your unsaturated fats, all right, are going to allow for it to be liquidy, okay, at room temperature. All right, if we're talking outside the body. But inside the body, okay, if I don't make them solid and they aren't sitting there and blocking up arteries and clogging, then I'm still able to harness the energy from them. I'm still able to utilize them to build up my lipid membranes and all of that stuff. So what are we talking about? Again, fish, avocados, nuts, peanut butter, olives, things like that. Where are we getting our saturated fats from? Butter, pizza, French fries, potato chips, cupcakes, all the good stuff. And here's the thing. So let's just, why we're talking about it, and we're talking about eating healthy and whatever. Fish oil. Okay, taking fish oil. So people say, well, I have high cholesterol, so I'm taking fish oil, and it's not doing anything. All right, so let's talk about fish oil. Fish oil will contain your omega-3, 6, 9s, or whatever one you decide to take if you don't take the complex. All right, that's the good news. Okay? They're not eating up the bad saturated triglycerides. People get this impression that if they take fish oil, they could still eat potato chips, French fries. And again, we all know what I look like. So again, I know the science behind it, and yet I do what I do. Okay? So I'm not here to give, health advice or to ridicule anybody, but I'm just here to say, listen, I'm an idiot and I'm doing this, and I know the science behind it. But people insist, well, I took this fish oil and my cholesterol's still high. Well, did you cut out saturated fats? Did you cut out pizza? Did you cut out, limit your carbohydrates? Did you? Well, no. Well, then fish oil's not going to do anything. Fish oil is a supplement. It's not a cure for your cholesterol. It's a supplement so that if you're not eating fish or you're not getting a lot of the healthy, unsaturated fats, that they're getting into your body. Now, you, on the other hand, also have to limit. It'd be like I'm not getting. It works like any other vitamin, like vitamin D. I don't go out often. My vitamin D is low, so I'm going to take vitamin D supplement. All fish oil is doing is supplementing from your diet what you should be eating, but you're not. It's not going to take care of your saturated triglycerides that are sitting there. If you're still ingesting the same food that's giving you the unhealthy fats, taking fish oil is not going to do anything. So that's a common misconception about, well, I'm taking fish oil, how come my cholesterol didn't get better? Okay, so what is the difference between fat and oil? Fat is a triacylglyceride that's solid at room temperature. Made by more saturated fats, meat, milk, butter, and cheese. All animal sources are going to give you your fats. Again, we need those in our bodies. We can produce some of them, but we should be limiting the amount. Okay. And by meat, that could be red meat, it could be turkey, chicken, pork, it could be fish. Oil. Triacylglyceride that's at room temperature, needs to at least have an unsaturated fatty acid in there, probably going to have multiple unsaturated fatty acids. Corn, cottonseed, sunflower seed, olive oil. They don't have color. They don't have a smell unless they've gone rancid. Or you oxidize them, burn them, things like that. And they don't have a taste, really. Okay. So we do need fats in our body to build the cell membranes. We do need them to insulate the body. So again, there is you can be overweight, but you can also be, no one ever talks about the people who are underweight. Okay, there has to be a healthy balance in there. Recommendations. Now this goes, depending on who you talk to. You should have nowhere between 20 to 35% of your caloric intake should come from lipids. The American diet is well above that. If you take in a lot of saturated triacylglycerides, again, it's linked to heart disease. Why? Saturated solids clogging. It's the way to look at it. Okay. So saturates stimulate cholesterol, which then could lead to the plaques building up inside the artery. Right. There was a movement at one point in time, still kind of is depending on who you talk to. Palm oil and especially coconut. Coconut oil was this big fad in the early 2000s to use that for cooking because it's healthy and blah, blah, blah. Coconut oil is full of unsaturated fats. How do you know? If you've ever cooked or used coconut oil, what is it at room temperature? It's not an oil like olive oil or vegetable oil or sunflower seed or corn oil. It's a solid. You throw a solid slab onto the pan. So although people pass coconut oil as being this, healthy alternative, it's really full of saturated fats. Okay. So unsaturated fats lower cholesterol production, therefore lower your cholesterol, and then could help prevent cholesterol plaques from building up and prevent or lower heart disease. But there is a fine line here. Just because I contain a double bond doesn't mean I'm healthy. So now we get into trans fats being bad. So if I have a choice between saturated and unsaturated, I want to choose unsaturated. But then I got to go to step 2 if I choose unsaturated. Is it filled with cis? Then we're good. Is it filled with trans? Then we're not good. Trans fatty acids, which means that they're unsaturated and they're in the trans form, they lose their health benefit. And the reason being is that when trans fatty acids enter the body, they do the same thing as saturated fatty acids. So trans and saturated fatty acids do the same exact thing. They stimulate production of cholesterol in the liver. So when it comes to fats, if you really want to stay healthy, you want unsaturated cis fatty acids. You do not want saturated, you don't want trans. Okay. All right. So we are about halfway into this lecture, and that's where I'd like to stop. Okay, it's about an hour in here. We will finish this on Wednesday. And then, when is, let me look up real quick. I know I have it here. Let's look. When is our final? I had it open here a second ago. Must have closed it out. Here we go. So we meet on Mondays at 9:05. Wednesday, May 13th. 8 a.m. to 10 a.m. and I have to give it at that time. I can't make it later. I can't make it earlier. I have to give it in a window between 8 and let's say 8:30. So you're going to have to get up and get that at that time. We've already been emailed and told and everything like that we have to follow that time. Okay.